morning, students. Today we will be calculating the electric field intensity at any point on the axis of the dipole. So previously I have defined you what is a dipole. Two charges having equal magnitude, opposite in nature, separated by a small distance is known as the electric dipole. So here in this electric dipole, two charges, one minus q, one plus q, are placed at the point A and B. Let the dipole length is 2a and O be the midpoint of the dipole. So along this axis here, let another point C is present. So now we have to find out what is the total electric field intensity at the point C due to this dipole. Is it clear? Let the distance of this C point from the center of the dipole, from the point O, let the distance is r. And we know that the expression for the electric field intensity due to a point charge, due to a single charge, is our E is equal to k q by r square. This formula you have to remember. E equal to k q by r square. So similarly I can say now the distance of this point C from the charge minus q is r plus a, because up to this distance is r and this much is a. So the total distance is r plus a, and the distance from B to C is our r minus a. Why? Because from O to C the distance is r and O to B the distance is a. So this distance will be r minus a. We will get the distance of the point C from the point B. Is it clear? So now what we have to do? We have to find out the electric field intensity at the point C due to minus q charge and again due to plus q charge. Separately we will calculate and we have to add them by vector method, and you will get the net electric field intensity at the point C. So first I will write what will be the electric field intensity at the point C due to minus q charge. So I will name it as E vector minus q means electric field intensity due to minus q will be equal to k q by, what is the separation distance from A to C is our r plus a. So this is k q by r plus a whole square. You see, this is a scalar one, only magnitude part, and our electric field is a vector quantity. Hence, we have to use a unit vector. If I say that, let along this is our x-axis. So, on moving from A to C is our positive x-axis, and moving from C to A will be our negative x-axis. And we know that along x-axis our unit vector is our I cap. So now I can say that the electric field intensity due to minus q will be equal to k q by r plus a whole square. And what about its direction? Now just see, we know that the direction of the electric field is always from positive charge towards the negative charge. That means electric field due to minus q, it will be directed towards the negative charge. So this is the direction of the E minus q, and it will be directed along C to A. Hence it is the opposite x direction. So I will use minus I cap. I think all of you clear? This minus I cap is due to what? The direction of the electric field intensity, or the electric field is in the negative x-axis. So let it be equation 1. Similarly, the electric field intensity at the point C due to the plus q charge will be distance is r minus a, hence it will be r minus a whole square. What about the direction of the E plus Q? Now electric field is always directed away from the positive charge, so it will go in this direction. So this is our E plus Q direction along x-axis. So it is I cap on. So these are the expression for the electric field intensity at the point C due to minus Q charge and due to plus Q charge. To find out the net electric field at the point C, you have to take the summation of both the equations. So I will write E net will be equal to E plus Q plus E minus Q. Is it clear? So what you will get? This implies that our E net will be equal to, what is the value of E plus Q? K Q by R minus A whole square I cap plus KQ by R plus A whole square minus I cap. Is it clear? Only I have written the value of E plus Q and E minus Q, which I have already written here. So this can be in the next step can be written like KQ by R minus A whole square I cap minus KQ by R plus A whole square I cap. Is it clear? And you can see that here KQ, I cap are present. So I can take them as common. Then I can write that will be equal to KQ whole into 1 by R minus A whole square minus 1 by R plus A whole square into I cap. Is it clear? By taking KQ and I cap common, I can write 1 by R minus A whole square minus 1 by R plus A whole square I cap. Again, you can see that here our E net will be equal to KQ. This will be what? R minus A whole square into R plus A whole square. Here you will get R plus A whole square minus R minus A whole square into I cap. And we know that A plus B whole square minus A minus B whole square is simply our 4AB. And this will be what? A plus B into A minus B. We know that A plus B into A minus B is our A square minus B square. So I can say that E net will be equal to, this will be equal to 4AB, 4R into A divided by R square minus A square whole square into I cap. Is it clear? So now I will write this expression 4RA like divided by R square minus A square whole square into I cap. Why I have written like this? Now you can see that here you will get term 2 that 2 into A into Q. 2A into Q will give you the dipole moment P vector. P equal to how much? Q into 2A, already I have defined. So that's why I can write this Q2A as P vector. So I will write our E net is equal to K 2Q into A is our P into 2R divided by R square minus A square whole square into I cap. Is it clear? Now you can see in the next step. I will put the condition. If our R is very much greater than A, that is known as the ideal dipole condition. If we will consider our R is very much larger than A, then this A can be neglected. So you will get E net is equal to 2kPr divided by R to the power 4 I cap. This A square will be omitted and here 1 R and this R will be cancelled. So you will get, better I will write E axial because I am calculating the electric field intensity on the axial line. So I will write E axial. E vector axial will be equal to 2kP by R cube into I cap. Or if I put the value of K, then I will write E axial is equal to 1 by 4 pi epsilon naught 2p by R cube into I cap. Is it clear? Students, remember that here you can see that the direction of the electric field, the net electric field along the axial line and the dipole moment P vector, the direction is same because we know that the electric field is always directed from positive to negative and it is coming along I cap. That means in this direction the net electric field is there in the positive x-axis and the dipole moment P vector is always directed from negative to positive charge. So you just see the direction of the dipole moment is negative to positive. That means same along the positive x-axis. Hence we can say that in case of the axial line the direction of the net electric field and the dipole moment are same. So this is all about how to calculate the electric field intensity at any point of the axis of a dipole.